Okay, let's do this thing. Accompanied by music today. Let me know if it's too loud or horrible or doesn't work, and I'll adjust. Anyway, just to recap where we were, I run a wonderful train game, which I think I need to make it start in a nice position as a future task, because every time I run it, it's random. But anyway, yep, there it is. So we have a game, we have a game board, we have 4 little function buttons, which is cool, and we can draw tracks, the letter H. So yeah, first thing we definitely have to do is fix this up. Right, let's draw some proper tracks. What are we doing? Saving the thing. Okay, so we lived through all the tracks. Yep, translate. Excellent. Let's just get rid of this. We want to do a path. Actually, yeah, I don't know that. So then, to our path, we're going to add some stuff. So the tracks are going to look like, well, train tracks. We're going to have, let's have some planks, which I will, this is you. That first Control C, it's hard work. Let's go with 3 planks. So, position of a plank is I times the width, height. I don't actually know if I'm drawing up or down, up or sideways. I'll find out. So it's the okay. We want to float. Plank gap is, let's go with the width divided by number of planks. So then the position is I times plank gap. Yeah, that makes sense. And then, so we move to our, what do we use? Width. So we move to our position from 0, I guess. Yeah, makes sense. And then we draw a line to our position, comma, our height. So we're drawing a line like that, and a line like that, and a line like that. So that should be 3 planks. We need, I guess, a... How do we do this? Draw a path? Yep. Oh, we need paint. Plank. Every time. Let's go with black. One stroke. And our stroke width is 3. Let's try that. The problem with having music is I have to make sure I don't bop along. Whoa. That did not work. So, I'm sure in one of these episodes I said, I don't like math. Okay. So width should be something like, width is the width of the whole, it's the width of the whole surface. the width of one panel is our cell size. Let's try that. Okay, that looks better, kind of, but not obviously. But cool. So they're not offset by the right amount. I guess that's 0. We should start at 1. Yeah, we should start at 1. And go +1, and then this height needs to be cell size. You know what? I'm going to fix the positioning of this window because I'm sick of it already. I'll use that later. Hey! Okay, I think that looks pretty cool. Obviously it's too far to the right. We need to fix that. Let's, yeah, I guess we can... Maybe if we offset... We're probably drawing to the right of our little pixel. We probably should move back to the left a bit. Let me... While I'm here though... go to here, and we'll just go this dot position, start position. Oh, manual. Is it location? Yeah. And we want 108.6.559, and I want the size to be 1547.817. Which I just got from my magical little thing that tells me the size of windows. Excellent. Okay, that saves me 2 seconds of pain every time. So back to here, let's do this. I want this constant to be plank width. And I'll just put it down here. Put that on. Okay, so our first one, plank gap, minus... Actually, you know what? Let's just put it in the middle of the gap. Yeah, that'll probably look good. And then a width, plank width. Maybe we don't need plank width. Very good. Cool. They're probably a little bit... We don't need them to go edge to edge. Let's do some padding. Plank height, plank padding. Let's go 10, and this can be plank padding, and this can be minus. That's probably a bit small, but I don't mind them. And then obviously 2 vertical lines. I think that's what... Let's just refer back to our reference material. Yeah, they don't quite go to the edge. But they're a bit thicker and they're certainly not padded that much. I'll tell you what, a hot reload at this point for Windows forms would be great. And I don't want to implement it, but boy, it's tempting. Alright, cool. Let's draw some tracks. Okay, we need a new path here. And we're going to have 2 tracks. And we want our tracks to be... I probably want them to be a rectangle. Let's draw a rectangle that is... starts from 0, goes to the end of the cell. That's not goes to. Okay, our track padding. We probably do, right. Let's do that. Goes to cell size and yeah, plate padding times 2 plus track. Okay. So we want track padding 10 and we want track width is 4. And yeah. And what we need originally paint, yep. Clear. So we're going to clear out a white square, rectangle. Then I'm going to draw a black. I wonder if I need a stroke width. Then I'm going to draw a black rectangle for the actual sort of outside of the track. So this won't look like much, but we should at least see it clear. Oh, yep. Okay, that's way too big. But that's good to know. Let's make that 3 as well. Yeah. And excuse me, we want 2 of them. Track padding. So it's the cell. Game.cell size minus track padding minus track width, I think. Yep, that makes sense. Alright, so we have a track path, and we're going to move to, where do I want to move to? We want to move to 0, track padding, and we want to line to game.cell size, track padding. Yeah, that makes sense. And then do it again, but plus track width. Plus track width. I guess I could do that with a rectangle, but never mind. And then for the bottom one, it is, yep, for that one, game cell size minus track value minus track width. That makes sense. And then that, obviously, that, and then that. Yes, I think that's right. Let's draw it and find out. This is part of why I like procedural graphics, is trial and error. I'm not a great artist, I can't draw, so procedural is easier, and then I can just trial and error this stuff, and I'm basically doing pixel drawing, and you know, it's easy to adjust things. Have I already got a track? I do. What's my track called? Oh, that's actual track, right. Track print. It's a bit ugly, but whatever. And then I want it to be this, but track width. No, 1 pixel. Yeah, I just noticed this was spelled wrong. Do let me know if the music is too loud or anything, because I think I hear it louder than you do. Oh, look at that. Lovely. Oh, I can't drag. That's kind of disappointing. Alright, we have tracks. Obviously they don't turn around yet, they're horizontal, but that's okay. I'm gonna say that's good. I really like that. Excellent. I'm gonna do one more thing, just so I don't forget, in case I come back to it later. I'm gonna put a property on track called direction. Direction. And I'm going to create an enum for this, and I'm just going to set the first one to horizontal, just so I don't forget what I've actually done. I'll know that this now goes sideways, by default. Perfect. Really need the dragging. Yep, I should do dragging too. Alright, let's check that in. Horizontal tracks. Probably took a little bit longer than I wanted, but never mind. Horizontal tracks. What did I do here? Oh yeah, that's a bunch of stuff. I should actually make that a separate file. I kind of want to do some cleanup of this stuff anyway, so I don't know whether I'll bother doing it now. Maybe later. Let's do that as a separate commit, just for fun. And yeah, let's extract that as a method for now. We'll just call it render. Whoa, those. Ugh. Like, these need to come into here. Okay. And we'll call it a render. Excellent. And we don't care about any of these. I don't know why sometimes it puts on all those output parameters. They're not used, so I have no idea why it thinks that's important. I don't know if it's a limit in the analysis, or Oh, I guess, okay, I guess maybe so because of the using, if they go out of scope. Ooh, I guess I buggered up my white space. That's probably a bug. Let's use the explicit type. Good idea. It's not obvious, so type's better. Okay, let's create a new file here. So that's our track layout renderer. This is actually a track renderer. And I'll just put this in here. Actually, this will be a good introduction to start talking about dependencies. So, it's not static. Text canvas. Actually, I'm going to give it. Give it a width, and use width instead of cell size. Yeah, I think that'll be nicer. Cool. And then, oh, my control W is not bound. Key codes. Game.cell size. And so this is going to be a track renderer. And so, alright, let's do it the dodgy way first, which I have done before in this project. It's not great, but whatever. Track renderer, yep. Okay. It's private. Okay. Done anything wrong? Yes. Colon? Sure. Right, let's make sure this still works. Cool. Interestingly, this is unused because I'm not even using the track, which I probably should pass in. I guess I will. It's kind of, you know, at some point I'll need it, even if not now. Yeah. Okay. Remember it's not usings. Excellent. We're all good. Alright, so we can now commit this raw sum horizontal tracks. Cool. So let's talk about DI. And before I do, let me know if you want me to explain things more than I am or less than I am. It's kind of hard to know sort of how deep I should go on these things and how much I should ramble. I don't want to ramble too much, but it's also fun, so you know. Let me know if you have any feeling. So, dependencies. This is a dependency. And so the track layout renderer needs a track renderer. And it currently doesn't declare that dependency. It's just, you know, it's internal to it. It's part of itself. And that's okay, but it's not ideal for a couple of reasons. So firstly, if you come to testing, unit testing, you kind of want, you want to be able to, say, test this track layout renderer without having to worry about what this track renderer means. So you want to be able to provide it with a track renderer to use for testing purposes that may not have anything to do with your standard one. So the way this game board works is a better system for that. The dependency is injected or is passed in the constructor. So you cannot have a track layout renderer without a game board. Right? There's no possible way to construct one, so that's really good because that means we're declaring up front what the dependencies of a track layout renderer are. And it means that in tests I can pass in a different implementation. That's basically what dependency injection is. It's just literally, instead of having any dependencies that are hidden, they all get passed in. So this class is fully, DI essentially. The one other thing you would normally do, and I should, and I will soon, I think, is all of these should actually be interfaces in an ideal world for testing, because it's no good to have the track renderer it needs. You want some type of track renderer. But for now, we'll leave that. So this is fully dependently injected, whatever it is. This has its dependencies injected, so this is fine. I'm just going to check all the rest of these. I think there was one I cheated on, but I think for the most part they're all pretty good. Game. Yeah, so here's another one where I cheated. And here, track layout, this new here. Basically with dependency injection, you don't want to type in the new keyword. You want to always have everything passed in. Now, the other thing in this case, I have two things that are iBoard renderers, but realistically I want that to be any number, so I'm going to pass in a list here of iBoard renderers. Oh, that doesn't have a name. Yep. Board renderers, and then I'm going to initialize that field. I'm going to get rid of these two. Whoops. Get rid of that one. And then down here, I simply go for each iBoard render. I'm going to say renderer too much, and I'm going to forget how many R's are on the end. And then, oops, we just do this. And so obviously this is the other place where interfaces come in handy. I don't care what type of renderers these are, they're just a board renderer. And also the other cool thing here is the canvas save and restore pattern now makes sense, because we have an unknown number of renderers, they do an unknown job, so before each one we save and after each one we restore. Cool, so that's now fully dependently injected. Game board is already fine, so we're good. Now we should have some errors here. Let's... Oh, we have got a few vars here that should fix up. I'll do that later. So that's interesting, that didn't... When I construct a game, I've just changed that constructor. Why didn't that... Who constructs the game? Probably the form? Ah, there we are. That's annoying that didn't show up. So, here what I should do here is pass in my list of renderers, but here's our new keyword again, right? So realistically, we actually want this to take in a game. And so, there's no reason that our form can't be injected as well. So what we have now, if I build, we should have just one error, which is where the main form is constructed. Yeah. So here we have our form, which is our game. And our game, I can't call it with an empty constructor. It needs a game, right? Dependencies declared up front. Cool. I'm just going to do this in another method. And I'm going to call it create form. Now let's call it manual. I'm just going to call it so this is sort of manual DI, and I want to just highlight a few different types of DI. So for our form, we need a game. We need a rendering.game. And now for our game, we need a game board. And for our game board, we don't need anything, fine. For our form, we also need a list of board renderers. So, yep. Oh, come back, helpfulness. My board renderer. And we want to pass in two board renderers. We want the track, we want the grid renderer. Yep. And the track layout renderer. Now I think they have dependencies as well, but they're probably just not public. Yeah. So this needs to be public. What are you complaining about? Grid renderers internal class, yeah, so that's just complaining that they're not used. So that's public, and then this one needs to be public. Okay. And yeah, so our track layout renderer needs this needs a game board. And it needs a track renderer. Does this need a game board? No. So obviously we don't want two different game boards here, so what we actually want to do is go game board equals new game board, and use that here. Oops, Shift Alt thing. Cool. New keyword. Game and main form. Cool. So this now compiles. Hopefully, yep, and it runs, and we have our game, and it works as we expected. So this is sort of manual DI, right? Everything declares its dependencies. Because I haven't done the interface thing, everything needs to be public, which is kind of annoying. But I have this God method, essentially. This thing has to know how to construct an entire picture. And obviously as the game gets more involved, this is only going to get bigger. As I add a new class that does something, this is going to get another line in it. And so that's not ideal. The other problem here is this list. So this list is in a particular order. I want the grid to be rendered first, I want the track layout to be rendered first. It doesn't make sense, and it's not a good idea for the program.cs to know the internal details of the game to know how it renders or how it uses its list of board renderers. So there's a few problems with this, but ultimately it is DI. All of these classes that I've just annotated, they're all fully testable. If I start to use interfaces, things make a bit more sense. I might actually do that. Yeah, let's do that. Because it should be easy enough to just go abstract interface. Yep, track renderer. And then I want, that's already interface. I want this to take an eye track renderer. Cool, what else do we have? Board renderer game, we need this to be an eye game. Oops, wrong button. Nope, still wrong button. Abstract interface. Now an eye game. Yeah, I guess we want all those things. And this needs to take an eye game board. I guess this should take an eye list actually. By the same token. Although that one's a bit different. It actually probably should be an eye enumerable. Yep, eye game board, that's fine. Track. I'm going to leave track for the moment. Track is not injected. But of course we want more than one track, so we can't inject a track. We actually need to inject some type of track factory. Oops. Whoops. Where's my keyboard? I. That's an I. Actually, I will make this I enumerable because that's all I need to do with it is enumerate it, so it's a bit more honest. Honest code is good code. And so yeah, this should now still work. Cool. So this is manual DI. Everything's an interface, so we can do our tests. Everything declares its dependencies in its constructors, so you can't possibly create something and be bitten later by a missing dependency. And we have our one God method that knows everything. This is, I guess people would say, well, a lot of people would say this is not ideal. They're not wrong. This definitely has some problems. Let me just commit that though. So the alternative to manual DI is of course to use some kind of DI library. And this is where A will probably say something wrong, but B will possibly just, it's top 3, piss someone off. DI and IOC are very, I wouldn't say they're similar, but like they're used together. So DI is what we've done. We are injecting our dependencies. And then IOC is inversion of control. And IOC is where, well, I think, you build up a container and you express the dependency. You tell the container about the dependencies, and then the container is the thing whose job it is to create objects. So I can run another method here, which returns a form called create from container. And so what we do here is we have a services collection. Yep. Oh, service collection. Yep. So we new up a service collection, and then what we do here is we add in our services. So I want a scope service. Basically, I want to say when someone wants a iGame, give them a game. When someone wants an I'm going to press the wrong thing every time. Someone wants an iGame board, give them a game board. When someone wants a track renderer, give them a track renderer. So game board, track renderer. Now we need our grid renderers. So I can add a scoped board renderer. Now I should be able to do this and simply add in our two renderers, and the container will take care of knowing about collections or whatever. And then I can go new main form, and I can go col dot get nope. I need to so this is building up the thing. I need to build. Oops. I need to build the service provider. Yep. So service provider, and now I can return a new main form service provider dot get service, and I need a game. Actually, this I forgot to change. This needs to be an iGame. And yeah, so iGame. Okay, so this should hopefully compile. Looks good. I'm not 100% confident this will work because I haven't actually used this Microsoft DI, Microsoft Extensions DI package is kind of the new thing that is used by ASP.NET Core and things. So this is the other way to do DI essentially, or to use ISE to enable DI. Let's see if it works. I'm guessing it didn't because it didn't. So we can debug it and see what the exception is. Unable to resolve game board while attempting to activate track layout renderer. Track layout renderer, game board. There's a possibility that add scoped is the wrong thing here, or did I give this? I forgot to update this. That's all. So this thing was still asking for a game board, and nothing in my DI container had said, hey, if you're asked for a game board, here's what to do. So it didn't know. So that's my bad. Hey, there we are. So now it runs, and we still have tracks. So everything works. It's just a different way. Now, this is no doubt simpler because I don't have to worry about when I'm building up my collection. I don't have to worry about the interdependencies, right? This nested stuff here, this reusing this game board object here, this is a bit painful. This is much neater. But it also still has the same problems where if I add a new type of renderer, I have to come and tell it here. And it's still a God method, right? This is still one method that knows everything about everything. And I don't really like that. It also means all of these things, it has to have references to all these things, which is bad, so does this. A nicer thing to do would be to have all of our interfaces defined in maybe in the engine, or I guess the ones that take ski sharp classes, that's a bit more difficult, but define somewhere centrally maybe. And then the implementations, you wouldn't need references to them. This has pros and cons, for sure. And I like the way it's used in ASP.NET, where it's wiring up services. It's like, hey, I'm going to express all the things I want my website to have. That's my job. In this case, with this game, the game is the thing. The game is the project. It's the code's very existence is enough to make it, necessary. So for that, the way that I would prefer to do DI in this case is create from discovery. So the way that I would like to do it is I want to, let me commit that. What's it called? Service provider DI. So I would like to have discovery. And what discovery means is there are rules about my code, about my layout, that I can either express them or I can just define the conventions for them, but it is possible, and it should be possible, to automatically build a DI container for this tool. Basically, everything is expressed via the interfaces that it implements, and everything is a singleton. There is only one of them. Actually, maybe I should have used a singleton for this. Not sure. Is there add internet singleton? And yeah. Oh, is that a generic form? Oh yeah, okay. They should probably all be singletons. What was I saying? Yes, so there should be a way to discover everything. So that basically what I want to do is I want to be able to write my code and not have to come back to this God method and ever work with it. And I can do this in a number of ways. For the size of this project, I could probably just write my own IOC container. I don't need to do that. I could use mef. So mef is system.componentModel.composition. Composition. It's probably unmute it. Yeah, I can use mef. There's actually mef1 and mef2, and I can use one of them. But there's probably also a way to use this with attributes, and the reason I say that, and this is just a bit of a guess, because that doesn't show me, but if I look under dependencies here, dependency injection depends on abstraction. See, I thought that said attributes. Yeah, so I think it's trivial enough for me to basically use this service collection, but write some code that just adds a bunch of singletons. Let's just make sure this actually works with singletons. What is the thing I want? Yeah, okay. Yeah, cool. So, okay, the way mef works, well, it's very configurable. The way that most people use mef is they do it with attributes, and I don't mind this at all. Basically, on this track layout renderer, it implements board renderer, but we would have to manually say, I export a type of iBoard renderer. So this would explicitly tell mef, system.composition. This would explicitly tell mef that, hey, if anyone asks for an iBoard renderer, I am one of them. And I really like that, because it lets this class, it declares its dependencies, and it declares what it wants to be seen as. And I think there's an elegance in having that all in one class. And then here, what you would need to do for mef is put in importing constructor, basically to say to mef, hey, when you try to create one of these, this is the constructor to use in case you've got more than one. And then this will be automatically imported, or there's various import attributes you can put on each individual parameter there. And that's the bit I kind of don't like about mef, or at least it's kind of overkill for this project. I don't need... I'm just going to get rid of this. I don't know why it's complaining. I think that was your public. Yeah. Oh, and then because it's... Ugh. Anyway, yeah, I don't want to have to declare attributes on every class and attributes on every constructor. Sorry, attributes on the class I don't mind, but attributes on every constructor I don't want to have to do, because I know this project. I know its conventions. You know, I'm not worried about it. If this was being deployed publicly, or like, if these libraries had some kind of general purpose use, then that might be different, and I probably want more control over it. Things like, you know, if this was iDisposable, for example, as well, let's pretend, I don't need this track layout renderer to be exported as an iDisposable, which presumably an automatic system would do. But that's not a problem because, yeah, in this constrained scope of my little personal project, no one's importing an iDisposable anyway. So I think what I might do is just, I might use this Microsoft Log Extensions DI, and I'm just going to go and discover the classes myself and not bother with attributes, because I think that'll be enough. I like that with this I don't need attributes on constructors, and so this is going to be this weird hybrid DI, but that's okay. And it should be pretty straightforward too. All we need to do is, so we need to loop through each assembly in my assemblies that I care about, which I'll work out later. And then for each assembly, for each type in a.getTypes, I'm simply going to go if t dot, can I get a list of interfaces? Get interfaces. Excellent. Okay, so for each type interface in t dot get interfaces, can I use interface to interfaces? So all I want to do here is I need my collection still. Goal.add singleton. Hopefully there's an overlay that takes two types. Yep. So my interface type, and if anyone asks for my interface type, I want to give them my real type. And that's pretty much it. Let's put a breakpoint there because I'm curious to see how much I think. Oh, I need to create this, which is control dot, and so I'm just going to go yield return. So type of iGameBoard.assembly and type of iGame.assembly. So I only need references to any two things from each of these assemblies. And that's another nice thing about this. Right? I don't need a reference to all of these classes. I don't need them to be public, because I don't need to refer to them at all, which is kind of nice thing about Discovery. Let's see if this works. I've honestly no idea. I've never tried. You know, I've never used this extension, dependency injection in this way. So we'll see what happens. Well, it ran. T is not null. Thank you. What is T? So gameboard, iGameBoard, excellent. We'll bring out autos and see this bit easier. So here we are. So this is an interesting, you know, I don't need this icon. Fortunately, there's an easy way to do this. I can just say if the names, the full name, oh no, the namespace. If it starts with trains.net, yeah, ignore case just for fun, then I care about it. Oh, why have I don't know what is going on with my settings. Sorry, I abhor automatic phrase completion. It just annoys me no end. I never want it. Can I turn it off? Somehow. All languages. Automatic phrase. Go away. Cool. Namespace. Why is it green? Is it a null ref thing? I don't know. Let's keep running. So iGame is a game. Yep. Perfect. So there we have discovered DI. Now let's do this. Namespace might be null. Yeah. Okay. So we're just gonna do that, and if it equals true. So if namespace is null, it won't equal true. We won't go in. This is just a. I don't know what classes don't have namespaces, but certainly mine all do, so I don't need to worry. So discovery. I really like this. So this is now, it's not a God method, right? It doesn't know anything. It's still the one place that wires up everything. But other than this assembly, which in fact, I can be a little bit cheeky here and say, if it starts with, whoops, my namespace, which, yeah, I mean, that's, there's no reason to assume this is true. Oh, namespace could be null, but starts with doesn't take a null. Alright, I'm just gonna undo that because I'm really lazy. Yeah, there's no reason. Anyway, thank you all for watching, and I'm going to call it a night. I'm going to leave this for the thumbnail. We have tracks. As long as you draw in one direction, we have tracks. Cool. Thanks for tuning in.